All right, welcome back, everybody. Sustainable engineering. Sorry about today. I got called away from campus right before class. So here's the lecture that I was going to talk to you about. And actually, since then, I was doing just a little more searching with the solar sites, and I found a great one, of course. So I did put it up. Make sure that's not there for today. And I want you to go look at it. So this solar data site, it looks like this and it's really good. So I did have to zoom in. It was zoomed out when I came in. So I had to find Oregon, had to find Gresham. And then I found Mount Hood Community College and I positioned it out here in this field next to the Early Childhood Development Center. So it's really slick that you can place it. Then it shows you the sun. So that is the current position of the sun. So I'm doing this at just before 1600 or just before 4 o'clock. Actually, I have 4:03. I think there's time ticking somewhere that you can probably see. But anyway, over to the left, there is information about where we're at. And if you mouse over it, it'll explain it to you. Like that's the altitude angle between the horizon and the sun. So that's what we calculated the other day. Right now it's at 14.83. It's getting pretty low. So here's the daylight hours, here's the nighttime. The graphics super cool, I think. But check out this, more solar data right down here, irradiance. Right now 645. So that's interesting. Up here you can click on the date. You can change the date. I can go to last year. I can go to June, and then I can go to June 21st, which was one of the days that you had to do on the last solar lab, right? That we struggled with. But here it is, 961 at this time. So you can change the time. You can change the date. It's really slick. I love it. So check out this site. You can go and say live. So now it'll go back to today, the 12th of February, 24. And you can actually see numbers changing here, right? We're down to 589. This will drop at some point. The angle at which the sun is at is changing. It's dropping. So yeah, pretty cool. And then when you want to stop the live feed, you go over to here and say stop live feed. So I do not see where it will do averages. So that was the other thing that you had to figure out for me was some averages. So it does not seem to be doing that. It also doesn't do any kind of shadowing trees or anything else. It's straight sunlight. So, but for calculating angles for solar panels, this is a really nice site. Like that altitude. So we got to stop the live to get those to work. But this piece of information, that's really handy. All right, so check it out. I put a link under today, and you should be able to look at that and see how it goes. All right, let's talk about a hydro. So in our area, we have a lot of hydropower. It's Bonneville. And let's just make sure we understand basically what's happening at Bonneville. Now, Bonneville actually dams up the river. It doesn't do a micro hydro setup like this. But the concept is the same in that you have a reservoir of water up high and you're going to drop that water. And when you do that, there's a bunch of potential energy from the weight of the water that's going to drop at elevation. So a dam works very similar to these micro hydro systems that I'm going to be talking about. Same concept. When you drop water, there's a bunch of potential energy, and we can take that energy and spin a turbine. So in a dam setup, we don't restrict the pressure down into a nozzle. We just drop thousands of pounds of water down a column. It hits a turbine, spins it, and creates electricity. As long as you have water flowing in that water system, you're going to produce energy. Has nothing to do with daylight hours or dark hours. It just produces, right? So in the micro hydro world, we do the same thing. There's a stream, and we're going to collect some of that water carefully, not to suck in any of the creatures of the water. We're going to drop it down an elevation. That's called the head or vertical drop. And we're going to run it through a pipe of some kind. A lot of times it restricts down. So maybe you have a 4-inch pipe and you'll restrict it down to a nozzle. So from understanding water pressure, that head is creating a bunch of pressure at that lower region. So that pressure can then spin a turbine and then, of course, create electricity. So here's a little bit of BPA, kind of older data, but some data, right? Daily average hydroelectric output in gigawatts. So that's million is 10 to the 6, giga is 10 to the 9 watts. So yeah, a bunch of production. And it produces more in the summer because of all the heating, of all the air conditioning load. So June is like peak, right? But that's because of the AC in California. We saw a lot of it to California. Big producer of electricity. And this is just, river flow. So the reason we can do that is we have a very large river, the Columbia River. We dammed it up completely at Bonneville. And we capture a lot of water that we then can drop and create electricity. All right. So let's talk about this micro hydro system. We have some reservoir of water up here, and we built some kind of a caisson for intake. And that's so rocks and fish and critters don't get into the intake. We want that underwater typically. And so it stays underwater year round. And then there's a pipe, and we drop that pipe down a certain elevation. It doesn't take a lot of elevation. Up here, it says this formula works well for measurements above 50 feet of head and 30 gallons per minute. So we'll do some calculating on flow rate so you'll understand how many gallons per minute we potentially could get, let's say, out of the pond here at the college. So that's a fun project, and we'll do that. There's a calculation here, right? This is a very basic calculation on this kind of a system where water comes down and drops. This is branching it out so these jets hit multiple locations on that Pelton wheel. A Pelton wheel is one of the most common wheels that we use in this kind of power generation. So I thought it would be beneficial to actually see one, so I have one ready to go. So this is a hydro system that has a very large head. So when you have a large head, there's a lot of pressure on the feed pipe. So this is all concrete down here. This is the generator, and it's massive. I believe this is in Nepal, where they do a lot of micro hydro. This is an on-off valve, and that's so obviously you can work on things without the water just continuing to flow. And usually there's a double setup of this, 2 setups. And that's so you can take one setup down and work on it, replace things, and then, use the other setup while you're doing maintenance. So again, if your water supply is available, this is continuous spinning of a generator. This is the Pelton wheel in here. You can barely see it. And this is the jet. So it's going to take this large pipe down into this nozzle. Don't know if you can hear it. It's not turned on yet. Big concrete casing. Oh, there's the Pelton wheels. So that's good. They showed those. There's a variety of styles and shapes, low speed, high speed. You have to be fairly robust. This is a high pressure situation here. I wish they'd show the whole system coming down, but it's probably coming down. It's probably 300-400 feet ahead here. That's probably 1,500 RPMs, maybe 2,000 RPMs. All right. That's not what we want to see now. It's bad fire. All right. So when you have that, you can do basic, like if you know your GPM, gallons per minute, and you know your head, you can run some calculation on a standard. This is a turbo turbine, which it does say is a Pelton wheel, so it does have some similar characteristics. This is a common intake system right here, where water's coming into some kind of screen that keeps the rocks and muck out, and then feeds your stock. This would be a stream setup where they did not build a reservoir like this. All right. This is just talking about stream width and depth required and what kind of pipe you could potentially run. This is actually just not allowed anymore. We can't just divert water from streams anymore, but the concept is the same, and it helps you understand how hydro works. If you did have a reservoir on your property, you can use it to generate power. You just can't reduce the stream. So whatever you pull out of the water, whatever you pull out of the stream, you have to put back into the stream. So the normal kind of off-grid setup would be a turbine that's producing power. That's going to go to a charge controller, input a battery. There should be some place for extra energy to go if the battery source is full, and then we're going to invert it and send it to the house. So just a little basic schematic. There was another one I wanted to show you. I didn't prep this one, so it's gonna probably have some advertising, but this is a student project just to show you how simple these can be. So we've got soup cans here cut in half, a little PVC structure, a nice sized generator, and we're gonna drive it with a garden hose. So a garden hose delivers about, it can be anywhere from 30 PSI to 60 PSI. So city water can be pretty high. Mine at home is 50 PSI and I'm on a well. So when you nozzle that down, you can get a pretty good velocity. They're just filling a big waste bucket here with the water. And then, of course, they're going to show the electricity coming from the generator, which is 12 volt, typically. Well, that's right. He's watering the garden with the extra water. So I thought that was very stylish to reuse the water. That energy from the generator goes into the battery. So there's a battery there, right here, 12-volt battery. They have a little controller, I think. If not, then he's just running it based on voltage, and then he's going to turn it off. You don't want to overcharge a battery. This is just a meter, and that's just a meter. So I don't know if he has a controller back here or not. Shows you the output in amps and volts. So he's getting full 12 volts. Probably coming straight after. Oh, there's his charge controller. So he is controlling the charge. And then has a little inverter. To 120. So that's house power. And then he's got his laptop plugged in. Notice the battery is out of the PC. So there's no battery in the PC. Yeah, it's just a well done little experiment to show you can take water pressure, spin a turbine, create electricity. So very fun. This is kind of a next level example of, a individual project for hydro. But not, not with, it's definitely within reach. We could do something like this if somebody wanted to do hydro. This is pretty nicely done, but we have a laser cutter and we have plastic, so yeah. All right, the PC does come on. I think it's hard to see. There it is. Yep, all right. So that's kind of fun. And again, just showing you how hydro works. Like most of our renewables, it's gonna spin a generator. Like that's what we do, is spin generators. So, all right, that's it for hydro, pretty much. There'll be an assignment that pops up. I don't have it done yet. Probably won't come up till Wednesday or so. A little hydro project for you. All right, have a great day, and we'll talk more towards the end of the week.